Okay, so what we're going to do, we're going to try to construct a square using only perpendicular bisectors. The reason this is challenging is that, of course, we have to get every side to be congruent, and we have to get every angle to be 90 degrees. So we're going to be given a segment. Now, if we don't know the segment length, we'll just call it x. And of course, right away, we'll just do the perpendicular bisector construction. So, perpendicular bisector, it's like large arcs from opposite directions. Oops. And what happens is, of course, that we get our 90-degree angle. All right. So, this gives us a 90-degree angle. Now, what I want to think about here is this. If this distance is x, what is this distance here? You've been here before? What is it? X over 2, right? Okay. So the side length of our square is not going to be x. It's going to be x over 2. Is that clear to everybody?
Yeah.
Okay. So what I'm going to do now, in order to get this side to be the same as this, is I'm going to measure it here, and I'm going to take an arc, take an arc up to here. Does everybody get that? Yeah. So now this is the same distance as that. Is that clear? Okay. So now, the challenging thing is that we've got to actually have something twice as long so we can do a perpendicular bisector going this way. So, what I can do is I can swing my compass out here and continue this so it is this length. So now, think about this. If this is x over 2 and this is x over 2, how long is this?
X.
X again, right? And now I can repeat the process and make another perpendicular bisector to go that way. Basically, yeah, we're creating the sides of it. So I'm going to come here and do another perpendicular bisector coming this way. What's going to happen here is that what will be the measure of this angle right here?
90.
90 again. Is that clear to you guys, how that works? It's a perpendicular bisector. So we have 90 here, 90 here. What was this distance again? Where this took place? X over 2, right? Okay, and how long do we want this one to be coming out this way? We need to get out to x. So, and this is tricky, but this is really good technique. I'm going to take this distance, which is x over 2, and I go to here. And once I've got that, I can make it twice as long by going to there. What happens is when I extend this, it's a lot of thinking, but how long is this part right here?
X.
X. So again, if this is x, I can do another perpendicular bisector to come down this way, and I'll have 90, 90, 90, and the last one will also be 90, and I'll be done. So I'll do a perpendicular bisector on this segment. As you can see, there's a lot of stuff. By the way, you also notice that I can start to recycle some of my work. I'm going to actually do a larger one though here. So do this perpendicular bisector. And what happens is that this comes straight down, making again, what's this distance? X over 2, what's this distance? X over 2, what's the measure of this angle? 90 and 90.
You sure that one's 90 looks like?
Well, okay, so the quality of my construction is limited by the quality of my tools. I'm using this, right? So it's going to be a little bit off. But what you can see is that if my perpendicular bisector is accurate, each one of these sides has to be x over 2, and each one of these angles has to be 90 to give me a perfect square. All right? It's as good as my construction. So if I use my tools correctly, it should work really well. Anyway, that's the abstract version. We'll do another one with measurements so we can compute the measurements and get a little extra practice. So thanks a lot. All right, guys.